TaqMan is another technique used to find SNPs and indels. It is a qPCR-based technique. qPCR stands for quantitative PCR and is also called real-time PCR. Using this technique, one is able to see the concentration of DNA increase after each cycle of PCR based on the fluorescence of a probe. The probe only fluoresces when bound to DNA, and so the amount of fluorescence is linearly proportional to the amount of DNA. The TaqMan assay uses the same reagents as PCR, plus 2 TaqMan probes. Each TaqMan probe has a fluorescent molecule, indicated here by the yellow and blue circles with an F inside. They have a small segment of DNA, which you see in between those two circles. And finally, they have a quencher, shown as a black circle with a Q in the middle. The quencher prevents the fluorescent molecule from fluorescing while they are close to each other. This means when the fluorescent molecule is attached to the DNA segment, which is attached to the quencher, there is no fluorescence. This probably doesn't make much sense so far, but everything will come together on the next slide. So finally, each probe is specific to a SNP. So the top probe is complementary to the DNA strand with a T as the SNP, while the bottom strand will be complementary to the DNA with a C as the SNP. TaqMan, like PCR, starts as a double-stranded piece of DNA, which is the template. I've shown the complementary strand of DNA in a lighter color, in the hope that it will make this diagram more clear. Additionally, we're more interested in the top darker strand rather than the bottom one. So, like PCR, in the next step, the double-stranded DNA is denatured. So far, TaqMan is exactly like PCR. In the annealing step, however, both the primers and the probe bind to the DNA template. The next stage is the extending stage. If you recall, Taq polymerase will bind to the primer and start moving toward the probe. Taq polymerase has a 5' to 3' exonuclease. All this means is that when Taq polymerase reaches the probe, it will start cleaving nucleotides off the probe one at a time. And you can see those nucleotides represented by the little dark colored boxes floating around. Right, so this will release the fluorescent molecule from the probe, and this is now able to fluoresce since it's no longer near the quencher. By looking at the fluorescence of your sample, you can see whether you've got the one fluorescent molecule, the other fluorescent molecule, or both fluorescent molecules, and that's how you determine what SNP you have.